In section 5.4, we're going to be dealing with solving polynomial equations. So in this first example, I want to find all of the solutions, now real or imaginary, of 2x cubed minus 5x squared equals 3x. So if I'm solving for any of these problems, what I'm going to want to do first is get everything onto one side, or to have everything equal to 0. So here I'm going to move that 3x over. So now I'm left with this equation. From there, as we've already kind of talked about in previous sections, I want to ask myself, is there a greatest common factor, or GCF, that I can pull out? In this equation, I can pull an x out, so that's exactly what I'm going to do here. So now I have the equation x times 2x squared minus 5x minus 3 equals 0. Using the zero product property, I know that I have a solution at x equals 0, and now I'm going to solve inside here either using factoring or the quadratic formula. In this video, I'm just going to use the quadratic formula mainly because that's kind of like a fail-safe way. The quadratic formula will work if I have real solutions, imaginary solutions, whole numbers, irrational numbers. So that's just kind of a good method to use because you know it's always going to work. Looking at this problem, if you could see a way that you could factor it, that's kind of a shortcut that you can do. But again, so you could factor this problem. I'm just going to go ahead and use the quadratic formula because I can. When I do that, plug it into the quadratic formula, I should get something like this. Sorry about that. Simplifying everything down, I get 5 plus or minus everything in here is the square root of 49 all over 4. Now in here, the square root of 49 simplifies to 7, and then splitting this equation off, I get x equals 5 minus 7 over 4, or 5 plus 7 over 4. So finally, my answers here could be x equals 0, x equals negative 1/2, or x equals 3. And those are all of the solutions of that equation. Let's do one more example. Here I have 3x to the 4th power plus 12x squared equals 6x cubed. Again, I'm going to bring this over, and I'm also going to put it in the middle to keep it in standard form. So I have 3x to the 4th power minus 6x cubed plus 12x squared equals 0. Right out the gate here, I notice in my coefficients, I could divide everything by 3 to kind of make my numbers a little bit smaller to work with. When I do that, I have this equation. And then finally, as a GCF here, I could pull out x squared from everything. So now I'm going to be working with x squared times x squared minus 2x plus 4 equals 0. Again, using the zero product property, x squared equals 0. So one of my solutions here is at 0. Again here, I'm going to use the quadratic formula. When I plug that in, I get something like this. So I should get 2 plus or minus the square root of negative 12 all over 2. Now I have negative 12. I know I'm going to get some imaginary solutions here. That's okay. I'm just going to simplify this down. That negative 12 I can pull out to be negative 1 and 12. I'm also going to ask myself, okay, can I pull any perfect square out of 12? In this case, I could split this off into 4 and 3. So that negative 1 will simplify to I, that 4 will simplify to 2, and then I can divide the 2 on everything. So my final answer here is 1 plus or minus I squared root of 3. So my overall solutions here is x equals 0, x equals 1 minus I squared root of 3, and x equals 1 plus I squared root of 3. So kind of the newest thing that we're going to talk about in this video is the sum or difference of cubes. So these two equations are going to be super important. I would write these down, I would highlight them, I would get a tattoo of them, whatever's going to help you remember it. I have a cubed plus b cubed and a cubed minus b cubed, and how I could kind of expand these. A cubed plus b cubed I could rewrite as a plus b times a squared minus ab plus b squared. On the other hand, a cubed minus b cubed could be rewritten as a minus b times a squared plus ab plus b squared. So what's going to be important here when I'm doing the sum or difference of cubes is to notice when I have perfect cubes. So it might be important here to go over what some of those common perfect cubes are before we look at an example. So some common perfect cubes: 1 to the 3rd power is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 125, 216, 343, 512, 9 cubed is 729, and finally 10 to the 3rd power is 1000. Again, to the 3rd power means I'm multiplying that same number by itself 3 times. Again, all of these are perfect cubes, so if you see any of these numbers, know that I could take the cubed root and I get a perfect whole number as my result. So let's end the day by doing one example problem using this method. So here I want to find all of the real or imaginary solutions of x cubed equals 1. So same thing here, I'm going to move that 1 to the other side to get everything equal to 0. And from here, what I'll notice is that x cubed is a perfect cube and 1 is also a perfect cube. So I can use that sum or difference of cubed method. A cubed is equivalent to x cubed, so that would mean that a is equal to x. B cubed is equal to 1, so taking the cubed root there, b is equal to 1. Now I'm going to use x equaling a and 1 equaling b into this format, the a cubed minus b cubed, since I have a difference of cubes here. When I plug that in, I'm going to get x minus 1 equals x squared plus x plus 1. Using the zero product property, x could be equal to 1. And then finally here, I'm going to use the quadratic formula again. I have negative 1 plus or minus 1 squared minus 4 times 1 all over 2. So I'll get negative 1 plus or minus the square root of negative 3 all over 2. Here I have some imaginary solutions. I'm going to simplify that square root of a negative number. And I'm going to get my answers as x equals negative 1/2 plus I squared root of 3 over 2. And x equals negative 1/2 minus I squared root of 3 over 2. And I would be done. Those are my 3 solutions.